In this video, a spatial iterative learning control approach for drone racing within a virtual tube is introduced. The background is that many racing competitions are launched to fully exploit drones' physical capabilities. The competitions often come with a suite of data assets, and the virtual tube is established suitable for them, representing the motion space of the drone. The racing track in the competitions can be seen as virtual tubes. The spatial iterative learning control scheme is proposed inspired by the training experience of top racing drivers that when the racer is in the center of the road, it is safer to accelerate, and when the racer is close to the boundary, it is better to decelerate. The velocity command consists of two parts, path convergence term and pace controlling term. At position L1, the drone is in the safe zone of the virtual tube, then the learning law will help accelerate the drone's pace in the next lap at the same position. At position L2, the drone is in the danger zone of the virtual tube, then the learning law will help decelerate the drone's pace in the next lap at this position. Then two simulations are carried out. The first one is the comparison with an optimal method. The iterative process of the method is shown on this page. Through iterative learning, the lap time with iterations decreases rapidly and finally reaches convergence. The lap time and training time show that spatial iterative learning control is near optimal and need lower computation. The second simulation is racing an air-seam scene which is provided by Air-Seam Drone Racing Lab. The lap time decreases rapidly within online learning. The proposed method surpasses some state-of-the-art methods in the shortest and average lap time. The real-world experiment is performed in an outdoor area on a real quadcopter without modeling. Only in 4 iterations, the lap time is shown gradually reaching convergence.